Hey guys, welcome to Programming Knowledge. In this video, we'll be making our first programming project, which is essentially going to be a console-based tic-tac-toe game. So, in case you're not familiar with the game, let me just quickly walk you through the game. The game has a 3x3 board and two players who play alternatively. So, the objective of the players is that they need to fill one of the rows or columns or the diagonals with their marker. So if I just start the game with a computer, you can see that we are playing alternatively, and our goal is to just fill up one of the rows or columns or diagonals with our marker. So here if you see, the computer has managed to fill the row with its marker, so it gets to win the game. So we're going to implement this game on the console, and well, we won't be implementing such a sophisticated system where the computer can play, although I will be giving the intuition required for building such a system towards the end. But what we'll be implementing is a two-player game. So if you go over here and then change this mode to play against a friend, you can see that you make both the moves by yourself. So we will be implementing this, but I will also be giving you the intuition required to implement a system which can think and then make moves towards the end. Right? So let's get started. So first, create a new project naming Tic-Tac-Toe. So the project title is Tic-Tac-Toe, and let me just save it in my desktop and then click next, finish. So now we have our project with our source file, right? So let me just make the text a little bit bigger. Now we'll start off by creating the board. So there are different ways to implement this board. You can think of this as an array of 9 elements, and then three of them are stacked together as a row, or you can even think of this as a 3x3 matrix. Well, I will be implementing this particular board as a 3x3 matrix because we can understand rows and columns better by looking at the indexes rather than the slots. But you're free to implement it as a 1D array also. That is by creating 9 elements and then stacking 3 vertically. All right. So I have managed to draw this implementation over here. So what we'll be essentially building is a 3x3 array like this, and then these are the indexes, and since we cannot detect mouse clicks on our console, we will be numbering our slots. So let's say the user wants to enter his marker over here, so the user can press 5 and then we will remove this 5 and then put marker over here, let's say X. So the 5 goes and then we put X over here. So that's how we are going to implement it. But there are other libraries which I encourage you to look up, which support mouse clicks on consoles too. So in case you are interested to implement such a system where you can click on the area and then your marker appear, so you can check out those libraries. Well, discussing those libraries are well beyond the scope of this course, so we are not going to do that. So for now, we will be implementing this particular system, right? So let's start off by creating the board, which is a two-dimensional character array. So let's call this array as board, and then this is going to be two-dimensional, and every dimension will have three elements. So this is a 3x3 board. Let me just put it over here. So even if you don't put it, it doesn't matter. I'm just putting it so that we be clear with our implementation. So let me just name the slot. So 1, 2, 3, and then 4, 5, 6, 7, 8, 9. So notice that I am numbering the slots as characters, because if you put characters over there, it will take it as an ASCII value. I'm sure you know this, right? Now let us quickly make a function to draw the board. So let's say void draw board, and what this function is going to do is that it is going to draw the board neatly for us. So something like this. So these two vertical lines and then these two horizontal lines separate the rows and columns. We'll be drawing that over here. So you can use a loop, but since there are only 9 elements, let's just hard code it. So board 00. Let us give a space before board 00 so that it doesn't get squashed up to the left. All right. Board 00, and then we have a space vertical line, and then board 01 space vertical line, and then board 02, and then we have the next line because we just completed the row. What we did is we just printed this row with these two vertical bars. Now we need to put a horizontal bar. So let us just put that. See out horizontal wire is just going to be lines. This is all completely designing. You can do it as you want, right? And these steps continue for the next two rows too. So control C, V, V, and for the last row we don't need the horizontal lines. And here you just need to change the row number. So this becomes 2, this becomes 1, 1, 1 over here, 2, and 2. So now if we call this particular function, let's just remove this and call draw board. Now if you run this, we'll be getting our board. So well, the horizontal lines became extra. How many characters are these? 3 characters or more. So let us just remove those 3 characters over here and then over here. So this board looks much better, right? So we have our board ready. Now how do we put data inside this board? So let's make another function to do that. Let's say void place marker, which is going to take a slot number, right? Because the user is going to enter the slot number. Now our task is to convert the slot number into the row and column number, right? If you are using a one-dimensional array, that is pretty easy. You just need to do slot minus 1 to insert that into the particular position, right? So suppose you want to insert it into this particular position, and if you are using a one-dimensional array, this is the fourth position, right? Because array indexes start from 0, so 0, 1, 2, 3, 4, and you just need to do slot minus 1. But since we are using a two-dimensional array, we need to find out a way by which we can convert this slot number into a row and column number. So what we can do to find the row number is that we can use an observation that all the rows start from a number which is just one greater than the previous multiple of 3. So if you observe over here, 1 is nothing but 0 times 3 plus 1, 4 is 1 times 3 plus 1, and then 7 is 2 times 3 plus 1. So what you can do is you can get the row number by dividing the slot number by 3. But then again, if the slot number itself is a multiple of 3, then you need to subtract 1 from the slot number. That is, if you take example of 6, so if you do 6 over 3, it is 2, right? But we need it in slot number 1. So we need to subtract 1 from that. So what I mean is, if this particular slot percentile 3 equal to 0, that is if the slot is a multiple of 3, then slot equal to slot over 3, so this is this, and then minus 1, so this will give us the slot number, else slot is directly slot over 3. So this should give us the particular row number. Sorry, let us take a variable, just directly changing the slot. So if slot percentile 3 is 0, then row is going to be this particular value, or else row is going to be this value. Now let us just see whether our row works correctly or not, and let us just call it with place marker, let's say 8, right? Now if you run this, you should be getting 2, which is correct, right? Because 8 is in row number 2. Now to get the column number, you can do something similar to that. So to observe the columns, these are nothing but reminders which you get after dividing by 3, right? So you can do the same thing. So let's take another variable to store the column, and column is nothing but slot modulus 3. So this should give us the reminder. So if you look over here, let me just pull up that image. Now, if you say 3, then our row is going to be 3 over 3, and since 3 is a multiple of 3, so it is going to be 3 over 3 minus 1, which is equal to 0. And then our column is going to be 3 modulus 3, which is going to be 0, but that is not our column, we need 2. So what essentially we need to do is, if it is a multiple of 3, if the slot is a multiple of 3, we need to put it in the end, or else that particular logic will work. All right, so over here what you need to do is, if this particular slot is again a multiple of 3, then our column is going to be 2. Alright, or every time when the value is a multiple of 3, you're going to put that in the last column, and then you can divide this slot number by 3 and then get the remainder. That is going to be your column number. And get the remainder and then subtract 1 from that. That is because we are not considering the uh, multiples of 3, right? We are leaving the multiples of 3, so we need to subtract 1. Let's say 4, so 4 divided by 3, you get a remainder 1, and then 1 minus 0 is 0, which is the column number of 4, right? So this is how you get the column number. So let us just quickly rewrite this with fewer conditions. So row is going to be this particular value, right? Irrespective of whether slot is going to be a multiple of 3 or not. If it is a multiple of 3, we can just subtract 1 from this value. So if slot modulus 3 is equal to 0, then row becomes row minus 1, and then column becomes 2, right? This is only when the slot which you're giving is a multiple of 3, or else, or let us define the column before using it, or else what happens is columns become slot modulus 3 minus 1. So first we perform slot modulus 3, and then we subtract 1 from that. Alright, so this is how we can get the row and column from a slot number. If you now check out the row and put a comma over here and then column, and then let us call with 8, so we should be getting 2 comma 1, which is what we got, right? Because 8 is in the second row first column, we can try it with some multiple of 3, let's say 9, and then try to run this. We should be getting 2 comma minus 1. Now why did that happen? Well, that is because we are trying to modify the column even after it is getting modified over here, right? We are modifying the column when slot modulus 3 is equal to 0, and then again we are modifying it over here. So we need to put it in the else part. Alright, now it should work fine. Now let us just close this and try it again. If I press F9, so here you can see it gave us 2 comma 2, which is correct. So now we know that our logic for getting the row and column is correct, so we can proceed by putting our marker into the board. So how do we track which marker to put? So let us create a global variable for tracking the marker. Let's say current marker, and let us set this to some value, or else we'll set it while we are asking, we'll set it while we are asking the user to choose the marker, right? And we will also have a current player, right? So we need to even track the current player to check which player is playing, right? So we have one marker and one player. Now what we are going to do is we need to just put board of this particular row, and then this particular column is going to be the current marker. So now we have successfully placed it. Let's place a marker over here and then try to draw the board. We'll draw a board over here too. So draw board, and then we'll put a new line so that we don't get confused between the two boards. So let's just say that current marker is X for now. And if we try to run this, you will be seeing that in place of 9 now there is an X, right? So now we know that this particular function works. We can place our marker on the board. Now let us make a function to determine who won the game, right? So let's call this function win or winner, something like this, and we will put the data type to char. I will just explain why we are putting the data type to char right now. So this is not going to take anything. This is going to work on the global board variable, which is this, which is an array, right? So what we're going to do is we are going to check all the rows, the columns, and the diagonals, and see whether those have the same value of marker, right? So in case they are numbers, they are going to be different, so nobody won. And in case they have this x's or o's stacked up horizontally, vertically, or diagonally, it means that that particular player won, right? So now since we are getting the winner, we can either put it true or false to determine whether the game is won or not. But to determine who won the game, we need to again check whether that particular marker is an X or O, right? So what we are going to do in this function is, instead of checking twice, we will directly return the marker of the winner. So by marker we can identify which player won, and then we can congratulate him or her, right? That is pretty easy now. So to do that, let us quickly run a for loop. So int I equal to 0, I is less than 3, I plus plus. And inside this, we are going to check for rows first. So if this particular board of I and then 0 is equal to board I1 and board I1 is equal to board I2, then return the current marker, right? Because we are going to check whether the player wins immediately after he places the marker. So if this particular condition is satisfied, then it means that one of the rows has been occupied by this current player, so he's the winner. And you can also check for the columns in the same loop. So what you need to do for the columns is the same thing, but just the i's get shifted to the second dimension. So since I'm checking the rows, I'm just putting I in the first dimension. For columns, what we need to do is we need to remove the I and place it over here. So let me just cut and paste it, and this goes over here and this goes over here. So now we have successfully checked whether the rows or columns are filled. For diagonals, you can just hard code it since there are only two diagonals. So if board of 0 0 is equal to board of 1 1 and board of 1 1 is equal to board of 1 2. So what we are doing is we are essentially checking whether this value is equal to this value and then this value equal to this value. If these two conditions are true, it means that these three values are equal, and it means that the player has won. So if this condition turns out true, then the current player has won. Current player or marker. Oh, since I'm using the player as a integer, I need to return int, not char. So over here, it is not current marker, but current player. You can return either of them, right? You can return current marker or current player. It just depends upon you, right? So now we need to check this condition for the second diagonal. So this goes, and then for the second diagonal, the coordinate are 0 2 1 1 and 2 0. So 0 2 1 1 remains the same, and 1 1 is equal to 2 0. Then you return the current player, right? So now what if nobody won? So you need to return something. So what we'll return is we'll just return 0. 0 means nobody won, and if it is either 1 or 2, it means that player 1 has won or player 2 has won. So now we have the winner. Let's just create an arbitrary board and then check who won, right? So let's place these markers, right? Place marker at 9 8 and 7. So it means that x has won. So 9 7 and then place marker at 8, and our current player is going to be 1, right? Now if you run this, okay, the spelling is wrong, current player. And if I try to run this, so here you can see I have placed 3 x's over here. Now if I try to call this function, which is winner, and try to print the data over here, so you can see that it has outputted 1. 1 is the current player who has just put 3 x's in a row. So it works for row. Let's just check for column. Column is let's say 0, sorry, 1 and then 4 and 7. So this is the first column, and we'll run this. So it has returned 1 again. And let's check for the diagonal. So that is 159. So now you see that doesn't work for diagonal. That is because we messed up the logic somewhere. Let's check that out. Oh, it is not 1 2, it is 2 2 over this, right? So that's a small mistake I made. Now if you again run this, this should work now. So here you can see it has outputted 1, and let's keep some arbitrary place, let's say 169. So this shouldn't result in a win, so this should give us 0, which it gives. So now we can say that our winner function is pretty much validated and it works, right? So now let us quickly make the interface we need. So let's call this interface game. Alright, and in this let us define our current player and marker. So we will give a choice for the player 1 to choose his marker, and player 2 automatically gets the other marker. So what we are basically trying to do is, if the first player has a choice of playing X or an O, right? So that's what we're going to do. So player 1, let's say, choose your marker. You can come up with your own sentences over here, it doesn't really matter. So this will enter our current marker, right? Or let's just keep a player 1 marker. Let's create a character which says marker of player 1. So we are going to get this particular marker, so marker player 1. Now our current player is going to be 1, and then the current marker is going to be the marker which the player 1 chose, right? Now if you observe this game, right, they can be at most 9 moves for this game to end up in a tie, right? So in case somebody wins, it's going to be less than 9 moves, but if it is going for a tie, it's going to be 9 moves in total. So what you can do is you can run a loop till 9 moves. So int I equal to 0, I is less than 9, and then I plus plus. And inside this, what you need to do is, let's first draw the board, or what we can do is we can first take input from the user and then draw the board. So for the first time, let us just draw the board outside loop, and then for the subsequent moves we'll draw the board after the slot is entered. So we'll ask the player to enter the slot. So see out its player, and then which player is that? Current players, let's say turn. So enter your slot, and now we are going to get a slot. So in slot, see in slot, and you know what to do. You just need to place the marker. So place marker in this particular slot, and then we will draw the board. So draw board. So now if we run this particular board, we will just call the function game to play a game, right? So we'll just remove all this and then just say game over here. So now if you run this, what you will be getting is player 1 choose a marker, it's going to be X, and then it's my turn, so let's say 2. Now you see that the player is not changing. That's because we did not write code to change the player and the marker. We need to swap the players and markers, right? Because the players and markers are going to change alternatively. And here you can see that the slot has been accepted perfectly, and then the X has come in place of 2. So here you can see that it works, and then if I win somewhere, it is not going to stop, and then it's again going to continue, right? So this game is never going to stop. So we need to fix all these issues. So we'll do that one by one. First, let's take care of the issue where the player and markers are not changing. So let's create a function quickly which swaps the player and marker. So let's say void swap player and marker. So this is the name of our function. So what it does is pretty simple. If the current marker is X, then change the marker to O. Current marker becomes O, or else you just change the current marker to X, right? This is just swapping the markers, and the same goes with players too. So if the current player is 1, then current player becomes 2, or else current player remains 1. So here we have successfully swapped the player and marker. So once everything is done, what we do is, before drawing the board, we just swap the player. Right, so swap player and marker, and this should do the job. Now let's test this. So if I run this, let's choose X. Now it's asking player 1's turn, enter your slot, let's say 1. And now player 2's turn, enter your slot. If I enter 2, you can see that 2 is occupied by an O now. So now we have successfully created a system where the players are changing and the markers are also changing. And now we need to take care of the issue that once we are winning, it is not stopping, right? So we need to check whether somebody won or not. So over here, what we can do is we can create a variable for storing the value which this particular function returns, right? This winner function returns. It's going to return a value in the range of 0, 1, 2, right? It's not going to return any other value. So let's just create a variable which stores the winners. So let's say player 1. This is the integer value, and what we need to do is after placing the marker we need to check whether he won or not. So player 1 equal to this particular winner, right? And now here, if this particular value which is player 1 is equal to 1, which means that player 1 won, right? So see out player 1 won, and then let's say congratulations. And what you need to do is just break out of the loop, because we don't need to continue the game after somebody has won, right? So you can just break out of this loop. And over here the same thing goes with player 2 too, right? You, if player 1 is equal to 2, then you says see out the same message, just we need to change the player 2 and all these things remain the same. So control C and control V, and over here instead of 1 we just need to put 2. So, in case nobody won, it either means that the game can go on, or if it has reached 9 moves, it means that it's a tie, right? Automatically, if you're playing for 9 moves and you make the ninth move and still nobody wins, it's going to be a tie. So, what you need is, if this particular winner condition, which is player 1, is equal to a 0 after completing this game, then we need to say that nobody wins, or let's say that is a tie game, right? So what this will do is, in case nobody wins even after 9 moves and this comes out of the loop, it will then say that it is a tie game, right? So suppose player 1 won and then it broke out of the loop, then if you just put this particular thing without this if condition, what will happen is it will print both the messages at once, right? So it will say player 1 won and then again it will say that is a tie game. We don't want that to happen. That's why we have put a if condition to check whether it's a tie or not, and then we will say it was a tie game, right? That will take care of all the issues, hopefully. So let's just try with O this time, and it's player one's turn. So let's enter 1, 2, 3. So you can see it's filling alternatively, and 4, 5, 6, 7, and it says player 1 1 congratulations, but we cannot see what happened over here. That is because we are not drawing the board immediately, right? So what we'll do is we'll shift this draw board function before this particular winning condition, right? So what will happen is once I place this marker, I will just draw the board. So now if I run this, let's say X and then 1, 2, 3, 4, 5, 6, 7, and now you see that player 1 has won. That is because this particular diagonal which I'm highlighting has been filled up by X's. So player 1 won. In case you fill it up with O, it means that player 2 has won. And in case you don't fill it up, let's take a draw case. Let's say we play for 9 moves. So X, let's just quickly put the numbers 1, 2, 3. So in case to draw, we need to put 5 and then 4, 6 and 8, 7, 9, right? So now you can see that nobody has won even after 9 moves. So it says that is a tie game and the board is filled up. So our game works perfectly for now, right? So there is a minor bug in this game. For what we did is, so let's say I put my marker in the first slot, right? And now it is player 2's turn, and what I will do is I will again press 1. So what will happen now is, if you observe, the X has gone and then O has taken its place. It means I'll just overwritten it, right? We don't want that to happen. We don't want to move the markers away from their places. So to fix that, what we need to do is we need to check whether that slot is empty or not. That is, if that slot contains some character which is not an integer, it means that it is a marker, right? And we don't want to change that marker. So what we do is, where we are placing the marker here, what we need to do is we need to put this only when that particular row and column is not filled up. So if that board and column, if board of this row and then column is not equal to an x, and it is also not equal to an o. So board of row and column is not equal to an o, then you will be filling it up with this particular marker, or else you won't fill it up, right? So let us return true or false over here, and then we'll print the message over there. So we'll make this boolean or bool, and over here, if this is the case, then you first place the marker and then return true, saying that this operation was completed successfully, or else what you need to do is you return false over here. And here, once we are placing the marker, where did we place it? We were placing it over here, right? So let's say boolean status, or you can directly put this in the if statement also, right? So if this particular condition is true, then we don't have to do anything. We have to print a message only when it's false. So let's put a not over here. So if not place marker of slot, that is, if this condition is not true, then we need to say something. So let's say that slot is occupied, and then try another slot. So this particular message will print, and then we need to decrease I by 1. That is because we need to give the player another chance, right? We can't just switch the players right there. So we just decrease I by 1, and then we just put continue, so that all these statements are skipped, and then it goes back to the execution. So let us just neatly arrange this, indent this code. So we print the message with decrease I, so that the value of I remains same once continuous encountered, right? Because if it is decreased over here, it will go back and it will increase over here. So effectively the value of I remains same, and it should work now. And another thing is, let's say the player entered some pretty big slot, right? Let's say 100 or something. So we need to take care of that too. So if slot is less than 9, less than 1, and if slot is, sorry, or if slot is greater than 9, we should not accept it. So we need to do the same thing, just the message changes. Control C and then Control V. And here you need to say that is an invalid slot, right? So that slot is invalid, and then you try another slot, and we just put continue, so that the player doesn't change. So this should do for us. Now if you execute this, you will be having a functional tic-tac-toe game over here. So it's asking player 1 choose your marker, it's going to be X, and now it's player 1's turn. So 1 2 3 4 5 6 7. So now player 1 won, that's because of this particular diagonal. And let's make player 2 also win. So let's try it once again. So let's say X again. So now it is going to be 1 2 3, and then 5 4, and then what is that, 8. Now you can see player 2 1, congratulations, that is because I have filled up this particular column with O's, right? So in case you wanted to implement a AI kind of a thing where the computer plays, you can do that. Well, we are just going to implement a pseudo AI, not the original one. So this is not going to think much, it is just going to randomly place it. So in case you want to generate random slot, what you need to do is you need to include another header file called stdlib, which is standard library. You can include this one or C stdlib, which is the C++ version of the C standard library. So these libraries are nothing but they are from C language. So in case using it in C++, you just add a C over here to indicate that that is a C library, right? Now to generate random numbers, what you have is you have a function called rand, which will directly give you a random number, right? Just print rand over here, and here you can see it just printed 41 onto the screen. Now if I execute it again, you will see that the same 41 is over here. If you close this whole program and then rerun it, it is going to give you a different number, but again till you don't remove this whole code from the memory, it's going to be the same number again and again and again. So to take care of that, what you have is something called as a seed. So for seeding the random function, seeding is basically you will be giving different starting points to that random function to generate different numbers every time you call it. So to seed the random number, you call the function srand, and inside this you put some number which constantly keeps changing, right? So let's say 1 over, so let's say 10 over here, and then if I try to run this, you will be getting some other number, let's say 71 over here. And if I put some other number, let's say 1 over here now, and then try to run it, you will be getting another number which is 41. But we can't change this again and again, right? We need a way to change this particular number which will generate different numbers every time. So to do that, we can use time, right? So time is constantly changing, it is not constant. So what you can do is, if you pass in time over here as an integer, it will give you different random numbers without you having to change this manually. So to do that, we need to include another header file which is called time, right? So c time, right? So same reason why we are using over here, it is time.h or c time, both are same. And you go over here, and then what to do is, instead of 1 you just pass in time and then pass in null as a parameter. We'll talk about this null when we're discussing pointers, but for now just remember this is the syntax. And this is how we call the function for time, right? For getting time as an integer. Now if we run this, you will be getting different numbers over here every time. So this is 9170. If I execute it again, you will be getting some other number, 9187, right? So to generate random numbers in a range, we want it in a range, right? We want random numbers between 1 and 9. So to do that, what you can do is, you have to use a formula. There is no direct way to get random numbers in C++ in a particular range. But what you can do is, you can use a formula which states that if you want random numbers in the range u to l, right? Which is sorry, l to u, which is nothing but lower range to upper range. What if you want random numbers in this range? What you do is rand mod u minus l plus 1, and then the whole thing plus l. Well, this formula does look pretty clumsy, I know that, but if you try to reduce this, you will see that it mathematically means the same, that the lowest number will be L and then the highest number will be U, right? So you just remember this formula to generate random numbers within a range. So in our case, what it's going to be is, upper range is 10 and then the lower range is 1, right? Upper range is not included. So sorry for this notation. It is mathematically this, which means that the last number is not included, but the number till the previous one is included. So it becomes 10 minus 1 plus 1, and over here the upper range is 1, right? So now if you do this over here, if I try to print this value over here, you will be getting numbers which are in the range of 1 to 9, right? Let us put a semicolon in the end, and we don't need this, so we'll just remove this. So every time we execute, we'll be getting some random numbers which is in the range of 1 to 9, right? So here you can see that it's giving us different numbers in the range of 1 to 9. So now what we can do is, we can use this, and instead of the second player, what we'll do is, we'll just ask the computer to generate some random slot number and then place our marker over there. And then instead of 9, now the loop will run only for 4 times. That is because the number of times the loop should run is halved, right? We are not going to take in inputs for 9 times. We are going to take in inputs for 4 times. So we need to just run it for 9 over 2 times, which is 4 as an integer division. If you want to implement a really sophisticated system like the one which Google uses, right? This one which can think. So if you take us this impossible level in this particular game, and then try to play with Google, you can see that you can never win, right? It will either end up in a draw, or you lose, right? Now, there is no other outcome in this particular. You cannot win, that is for sure. So to implement such a system, there is an algorithm called as Minimax algorithm. So you can try to study about this Min-Max algorithm. So sorry, it is Min-Max algorithm. right? So you have this particular algorithm. So what this essentially does is it will take combinations of games, right? It will play the game with itself and it will score every game. So let's say we have an arbitrary game. So let us just clear this. Let's say we have an arbitrary board. So I have an X over here, an O over here, and then another X over here and O over here, and then the computer is playing X, so it has to make the next move. So what it will do is it will try out all the possible boxes which are unfilled, right? And there are different outcomes for that. So one of the outcomes is, let's say I start off with this board. So let's change the color. So let's say I put an X over here. Now there are different ways to put O. I can either put one over here, one over here. It is up to me, right? So every possibility will generate a new set of boards which the computer will play itself, right, in the memory, and then it will score its outcomes. So let's say in case it put X over here, and then for the first case you put O over here, and then it turns out that after playing such combinations, it turns out that if you put X over here, you have let's say 10 combinations, out of which you won 5 combinations, right? So this is one of the slots. Now what it will do is it will keep the statistics and again play it with the next slot which is empty. So what it will do is it will just remove these things and then it will play with let's say this particular column. So it will put an X over here and then again repeat the same process. It will see all the combinations possible, and then let's say in this particular column which I marked with red, there are again let's say 10 possible outcomes, and then it won 7 of them, right? And let's say it played over here. Let's take some other color. Let's say this one. So it played over here, and then in this again there are 10 possible outcomes, and out of which it could win only 2, right? And you have another possibility over here, or in which 10 possible outcomes it could not win anyone, right? It lost all of them, so it won 0. Now what it will do is it will see all the scores. So here it has 70% probability, right? So if you are winning 7 games out of 10, it means you have 70% probability of winning. And here you have 50, here you have 0% probability, and here you have 20% probability. So it will check the one with the most probability or the most score. So if you talk in terms of numbers, here you have 5, here you have 7, 0 and 2, right? So it will take the number which is maximum, that is this one. So it will say that if I put my marker in this particular place, I have more chances of winning. So it will place it over there. So for every move, it will calculate all the possibilities and then place the best move. And that is how this particular Google is using that particular algorithm to make its decision. So that algorithm, even though it is called something else, it is actually recursion. So if you look at the implementation, it is basically recursion which is being implemented, right? So tic-tac-toe, if you just search for that, you will have many different resources to check that out. So you check that from one of these resources. So what you will see is it is basically implementing recursion. It will just go over the boards and then try to implement, and then you have a scoring method. So I think they have used plus 10 as a score. We have used plus 1 over here, right? We have if you won, you just put 1 over here. If you don't win, you just put minus 1. It means that you won, and minus 1 means that you lose, and you don't want negative scores, right? We just want positive scores. So this is a bit of complicated stuff. If you don't understand, I don't expect you to understand at this stage, but I would definitely recommend you to check that out and try to implement. And this one you can try to implement by reducing the number of loops over here, and then creating another function so that the AI chooses what slot to put the marker in. So hope you enjoyed this video. In the next video, we'll be starting pointers.